Hello students, today we are going to start thermodynamics. It is very important for NEET and other competitive exams. Most of the questions will come from thermodynamics. Let us learn in detail about this. Let us know what do you mean by thermodynamics. Thermodynamics is the branch of science which deals with interconversion of heat, work and other forms of energy and their quantitative relationship. Here it is the branch of science and we are going to study about conversion of heat into work and work into heat, their interconversion and their quantitative relationship, means how much amount of heat is going to produce or how much amount of heat is going to work and how much amount of work is producing heat. That quantitative relationship we are going to study. As you know, thermodynamics can be derived as thermo nothing but heat, dynamics nothing but in motion. It means here the heat energy flows from system to surrounding or surrounding to system, and its study we are going to study in thermodynamics. Okay, let us pass to the next part. Thermodynamics can be studied as physical thermodynamics and chemical thermodynamics. In physical thermodynamics, the transfer of heat energy from system to surrounding or surrounding to system in only physical process. Wherever there is a physical process and wherever there is heat is converted into work or work producing certain amount of heat, their quantitative relationship we are going to study in physical thermodynamics, and you are going to study in detail about that physical thermodynamics in physics. Next one is the chemical thermodynamics. Here, during chemical reaction, sometimes heat is absorbed from the surrounding, sometimes heat is released to the surrounding. It means the reaction will undergo release of heat energy or absorption of heat energy. During that, whatever the quantitative relationship is there, that we are going to study in chemical thermodynamics. This is about different types of thermodynamics. Next one, importance of thermodynamics. What is the importance in our daily life, or how thermodynamics is going to help us? First one, it helps to predict feasibility of a reaction under a given set of conditions. Under a given set of temperature, pressure or concentration, volume, whatever the properties of the system are there, under certain conditions, whether the reaction occurs or do not occurs. That can be predicted by thermodynamics. Second, it helps to predict extent of reaction before the equilibrium is attained. Extent means how much amount of reactant is converted into product before going to reach the equilibrium. At equilibrium, the concentration of the reactants and products remain constant. So, to reach that equilibrium, how much part of the reactant is converted into product, that can be predicted by thermodynamics. And third important one is it helps to deduce some laws, that is laws of equilibrium and distribution law. The laws of equilibrium we are going to study in equilibrium chapter, and briefly I will explain about the distribution law. Distribution, already you know the meaning, that is distribute. Whenever a solute is there, whenever a solid is there, or simply you can say solute, if that solute is soluble in two immiscible liquids. For example, sugar is a solid and it is miscible, it is soluble in benzene as well as water, but benzene and water are immiscible to each other. Whenever we add some sugar to this mixture, sugar distributes itself between benzene and water in such a way that where such a way that or that solubility depends upon that distribution depends upon its solubility. Means such type of phenomena are governed by a law. That law is called distribution law, that you are going to study in your higher classes. After studying the importance of thermodynamics, let us know its limitations. First limitation, it does not tell about the rate of the process, rate of the reaction, rate of the process or rate of the reaction. It means that what is the speed of the reaction per second, how much amount of reactant is converted into product, or how much amount of product is formed in 1 minute, 1 hour, 1 second, like this. It is not going to explain or it is not going to mention about the rate of the process or rate of the reaction. It means whether at what time the reaction is going to complete, that cannot be explained or that cannot be mentioned by thermodynamics. It is unable to predict. Second one, it does not mention about the mechanism of the reaction. Mechanism nothing but the different steps or path by which a reaction can occur. Different steps of the reaction cannot be explained by thermodynamics, so it does not mention about that. Third one, it does not tell about microscopic properties. There are two different types of properties: microscopic properties and macroscopic properties. Macroscopic properties are those properties which can be studied in bulk. Example, temperature. Temperature of a single molecule, single atom cannot be measured, but whenever the atoms or molecules are in bulk, we can measure its temperature. So, temperature is a macroscopic property. Macroscopic property means the property which can be studied in bulk. In the same way, microscopic properties. Properties means the properties related to atomic level or molecular level. Example, atomic radius, ionization energy, electronegativity, etc. These properties cannot be measured, or thermodynamics does not mention about these properties. So these are the some limitations of thermodynamics. After that, let us know some basic terms and concepts in thermodynamics. The basic terms are system, surrounding, and universe. System nothing but the part of the universe under our observation, under our study. For example, if you are a doctor, patient is your system. If you are a principal, college is your system. If you are a teacher, classroom is your system. Whenever you are taking the class, your observation will be in the classroom. So, classroom is your system. It means system nothing but it is the part of the universe under our observation, under our study. Next one, surrounding. The remaining part of the universe except system is called surrounding. For example, I am taking class. Class is my system. Remaining part of the universe, that is college, is my surrounding. College comes under surrounding. Other classrooms comes under surrounding. Gulbarga comes under my surrounding. It means except my classroom, remaining part of the universe is nothing but surrounding. Third one is the universe. That is, it is the combination of system and surrounding in together is called universe. So, we know about system, surrounding, and universe. Then system and surrounding are separated by a boundary. We can separate system from surrounding by boundary. Boundary nothing but it is a real or imaginary line which separate system from surrounding is called boundary. Any line or anything which can separate a system from surrounding is nothing but boundary. Let us study the characteristic features of the boundary. It means what are the properties of the boundary, how it works or how it functions. First one, a boundary may be a real or imaginary. Means boundary may be real, it appears, or imaginary, it may not appear, or it is invisible. For example, classroom is my system, remaining part of the universe, that is college is my surrounding, and my classroom is separated from surrounding by walls and it is a visible one, so we call it as a real boundary. In the same way, different parts of the atmosphere are separated by an imaginary line. So here that boundary is nothing but imaginary boundary. Anything which is invisible but it is going to separate a system from surrounding, then we call it as an imaginary boundary. Anything which is visible and it is separating system from surrounding, then we call it as a real boundary. Second property, that is a boundary may be diathermic or adiabatic. Diathermic nothing but conducting. The boundary may conduct heat energy from system to surrounding or from heat surrounding to system. So such type of boundary is called diathermic. For example, when you are cooking in a pressure cooker, the walls of the cooker means the utensil is nothing but acting as a boundary. So here it is allowing heat, so we call it as a diathermic. Or adiabatic. Second one is the adiabatic. Adiabatic nothing but here which is not allowing any heat energy to enter into the system or out of the system. Such type of boundary are called adiabatic. Thermos flask or hot boxes what you are using at home, they act as adiabatic boundary. Third one, a boundary may be movable or immovable. It means a boundary can increase or decrease the volume of the system, or it may fix the volume of the system. For example, balloon. The walls of the balloon act as a movable boundary. If the temperature inside that balloon increase, the volume of that balloon increases. So here the balloon is acting as a movable boundary. In other example for immovable boundary, that is LPG cylinders what we are using, the walls of the LPG cylinder is made of metal and that metal is immovable, so that cylinder acts as an immovable boundary. Next, here the boundary can exchange energy and matter with the surrounding, but not all boundary, but only diathermic boundary. Okay. Next one, types of systems. The different types of systems are open system, closed system and isolated system. What is open system? What is closed system? What is isolated system? What is their property? That we are going to study here. Open system. The system which can exchange matter and energy with the surrounding. It means the system is allowing the matter to enter into the system and the matter can be escaped from the system. It means there is a transfer of matter between system and surrounding, and there is a transfer of energy between system and surrounding. Such type of systems are called open system. Example for open system is heating water in a vessel, open vessel. Whenever you heat water in open vessel, heat is entering into the system. It means the boundary is allowing the heat to enter into the system. At the same time, the matter from the system is escaping into the environment. That is, water vapors are escaped into surrounding. That is, that they are escaping into atmosphere. Here, transfer of energy as well as transfer of matter is taking place. So, such type of systems are called open system. Here, one condition is that the open system is only possible whenever the system is separated from surrounding by diathermic wall or conducting wall. Next one, closed system. The system which can exchange energy but not matter with the surrounding is called closed system. Example for closed system, heating of water in a closed vessel. Whenever we heat water in a closed vessel, the energy enters into the system, but matter is not going to escape from the system. So such type of systems are called closed system. Third one is the isolated system. In isolated system, there is no exchange of heat or matter with the surrounding. It means there is no exchange of energy between system and surrounding. There is no exchange of matter between system and surrounding. Such type of systems are called isolated system. The best example for isolated system is thermos flask. Already you know about that. Thermos flask does not allow the matter enter into the system or heat enter into the system or heat comes out of the system. So such type of systems are called isolated system. An isolated system is separated from surrounding by an adiabatic boundary. By this, I think you understood. If you have any doubt, you can call to my personal number. Thank you.